Hi everyone. Today we will be discussing a problem that relates gravitational force and circular motion. Let's begin. So here in this problem, we have the planet Jupiter and one of its moons, Io. We were given the information that Jupiter has a radius of r and a mean density of rho, while the orbital radius of Io is nr. And again, it is assumed that um, Jupiter is a uniform sphere. So the time it takes for Io to complete one orbit will be t, and we are asked to show this formula over here. So this question is mainly about the derivation of a formula. But of course, we also need to consider the concepts behind it. So again, we have this scenario over here, and let's list down the equations that we will be using. So first one will be the equation for density. That's going to be mass over volume. Now, I chose to use capital M over here because we're talking about Jupiter. And by convention, when we talk about the object that sets up the gravitational field, we usually use the capital letter. Next, the formula for Newton's universal law of gravitation, which is gmm over r squared. So just recap, guys. G is the gravitational constant. M is the mass of the object that sets up the gravitational field, in this case, Jupiter. And the small m is the mass of the object that feels the gravitational field, which is the moon, or Io. And then r here is the center-to-center distance from Jupiter to Io. Next, we also have the formula for centripetal force. Now, in this problem, I chose to use mr omega squared since in the equation that we need to derive, there's pi. And of course, omega is equal to 2 pi over t. So just to remind us, guys, this is the goal equation that we need to derive. Okay, so in this problem, since Io is tracing a circular path around Jupiter, that means Io is experiencing a net force, which is a centripetal force. Now, what force provides the centripetal force? In this scenario, it's obviously the gravitational force. So the gravitational force provides the centripetal force. Therefore, the two of them can be equated to each other. So replacing um, the formulas for gravitational force and centripetal force, we now have this equation over here. Now, the small m here and the small m here, they mean the same thing, which is the mass of Io. So we can cancel them out. On the other hand, the r here is the center-to-center distance from Jupiter to Io, while this r is the orbital radius. So in this scenario, since Io is revolving around Jupiter, these two r's will mean the same thing. So we can actually combine them. We now have this equation. Gm is equal to r cubed omega squared. Now, applying this information about the orbital radius for this problem, and then replacing omega by 2 pi over t, we now have this equation. So small r is replaced by n capital R, and then omega will be replaced by 2 pi over t. So simplifying this, we now have Gn is equal to n cubed r cubed times the quantity 4 pi squared over t squared. And isolating m, we now have this equation over here. Okay, let's continue. So our equations will now be the equation for density still, and then we have the equation that we just derived for m. And of course, this is our goal. Now, we can begin with the equation for density. Now, we already have an expression for m. We just need to find expression for v. But v is simply the volume. And it was stated in the problem that Jupiter is assumed to be a uniform sphere. So we can make use of the volume formula for a sphere, which is 4/3 pi r cubed. So we'll now substitute this expression for volume and then this expression for mass. We now have this equation. So simplifying this, we multiply the numerator by the reciprocal of the denominator. So as you can see over here, some variables can actually be cancelled. R cubed can be cancelled, 4 as well. And then you have pi squared here and then pi over here. Then there will be pi remaining after we divide it. So we now have this equation, 3n cubed pi over gt squared. And rearranging the variables, manipulating the equation, we now have the equation that we are asked to show. Okay, so that's it, guys. I hope everything's clear. And as always, thank you for studying or learning with me today. See you next time.